Today we're going to be practicing what we did yesterday, that is writing piecewise functions. So we have a little practice paper. If you would like, you can listen in because I'm going to just go over number one, just kind of give you one more problem to listen to if you need that. The rest of them, again, are going to be practice for you. But remember, all we're trying to do is just write the equations for each one of these piecewise functions. So, how about this first one? If we are trying to write for this, the first thing we would need is we would need the slope. It doesn't matter what points you use. You're going to be going down 1 and over 2. If I go down 1 and over 2, that means the slope is -1/2. You're also going to want to highlight this point right here, specifically its x value. Honestly, its x value is -1, and you want to conclude that the graph is going to the left of -1. Well, left means less, so we're going to be thinking that as a less than sign. The only other thing to do is to come up with the y-intercept. Now, the y-intercept is where the graph crosses the y-axis. But instead of guessing, although we notice that it kind of goes backwards here, instead of guessing, what we can do is we can plug in a point. So I'm going to go ahead and actually identify this entire point as -1, -1. And I'm going to plug that point in to the equation that I'm starting to create here. That means I'm going to plug a -1 in for y. I have my slope. I'm going to plug a -1 in for x. I'm trying to solve for b. I got a lot of the same types of numbers here, but basically this equation is nothing more than -1 equals 1/2 plus b. If I subtract 1/2 from both sides, I get -3/2. So my equation has a slope of -1/2 x. It has a y-intercept of -3/2. And remember, we decided that we are less than the x value of -1. How about this second piece right here? This second piece. There's all kinds of things that you could conclude about it. You can conclude that it starts at an x value of -1. It ends at an x value of 3. You could conclude that the slope is 0 and that the line is always equal to, always equal to 2. Y equals 2. Well, when you have a horizontal line like this, that's all you need. You just need the y equals 2, and we're between -1 and 3. Of course, those -1 and 3 values would be the x values from our starting point and ending point. Now, the last line here looks like if we think about the slope of this line at a few spots, you should conclude that you go down 1 and over 1. Down 1 and over 1 means the slope is -1. The y-intercept, remember, we do have to kind of go back to the y-axis. It looks pretty clean and it's going to be right here. But to be sure, we can always take this point. What's this point right here? It's the point 3, 3, 5. And we're going to plug that point in to find b. Now remember, when you plug that in, you're plugging 5 in for y, you already have your slope, you're plugging 3 in for x, and you're going to solve for b. So b equals 8. So we've got our slope, mx, plus 8, and the only thing left to do is to conclude, now be careful, conclude that you are greater. You're greater because the graph is going to the right. You're greater than your starting value of 3, but please don't tell me that the graph is less than because it's going down, but rather tell me that it's greater than because the graph is going to the right. And so we have our third equation. You practice the other ones, and we'll continue to be working on piecewise functions.